Okay, so today we're going to be reviewing the energy pyramid and the order of the food chain. So we're going to start by reviewing the acrostic sentence that we learned yesterday, and it's please practice 7 times. So if we remember, that's the order of the food chain. So the first P stands for producers, and on our energy pyramid that Miss Rolfes is drawing over here, it's our first level right here, and that's where the producers go. So if we remember from yesterday, producers are plants that produce their own source of energy from the sun. And so then if we move on to our second level, that is primary consumers. So they go right here where Miss Rolfes is drawing. And primary consumers are herbivores. So if we remember herbivores, those are animals that eat only plants. And they eat the producers in the food chain. So our next level after that is where our S comes in, and that is secondary consumers. Secondary consumers are carnivores, and that means that they eat meat. So they eat primary consumers. And then right after that is our final level right up here, and that's where the T comes in, and that's tertiary consumers. And tertiary consumers eat other carnivores. So they're carnivores that eat other carnivores. So they are meat eaters that eat other meat eaters, and they eat our secondary consumers. All right, so at this time, you guys are going to get out your notebooks, and you are going to draw your own energy pyramid, and you can draw in some organisms and what would be at each level, and label what would be at each level as well.
Make sure you draw animals that will help you remember what goes in the pyramid.
So this is the time where we would review with students on whether they have any major questions before we go on to the next part of the lesson. And so now would be as if the students had already asked their major questions, we've already reviewed them, and everyone is good to go to the next part. So now we're going to do a sample of what kinds of animals would be at each level, which is going to help us for our next part of the lesson. So on this first part of the level is producers, so that's plants. So we're going to put grass in this part. Okay, and so our next level is, if we remember our acronym, is primary consumers. And so we're going to draw a rabbit. Very good, Ms. Rolfes. Good art skills. Okay, and if we remember the S in the please practice 7 times, we're going to remember that our secondary consumers are next, and we're going to draw a fox, which is going to eat our poor little rabbit down here after our rabbit eats the grass. Okay, and then after that we're going to go to the tertiary level, and so our bear is going to eat our fox. And this is all in a grassland ecosystem. And there you go. That is an example of an energy pyramid.
Now we're going to discuss the interdependency of each animal in the food chain. So I'm going to have you guys take a few seconds and brainstorm reasons to yourself about what factors contribute to our carrying capacity of a population. So if we remember, and Ms. Moore will write the definition on the board, carrying capacity is the number of individuals of a species that can be supported by an environment. So for example, if we take a rabbit, the number of rabbits that can be supported by this environment. So go ahead and take a few minutes and brainstorm that. I'm going to talk about how each animal in our pyramid depends on the organism below them in order to have food. So the rabbits need grass, foxes need rabbits, and bears need foxes. So, for example, if we have too many foxes, so we have an overpopulation of foxes, they would deplenish the rabbit population, and there would be no more food for the foxes, so they would have to relocate to find a new food source. And then the bears would also have to relocate because their food source is gone. So let's think back to our deer situation. Go ahead and get with your partner that you worked with in the beginning of class and discuss how this same situation applies to that situation with our overpopulation of deer. We're going to give you guys 2 minutes, and then we're going to have you come back and share those answers.
Okay, so right now we would be getting feedback from students on what they were sharing with each other about all that we were learning and the clip on the deer populations that they watched at the beginning of class. And while we're doing that, we're just going to be reinstating the relevancy of what we're learning before we go on to our next topic of the lesson. And that relevancy is for students to understand the importance of population growth and what that does to an ecosystem, along with what it does to the foods that we eat. And then that they can hopefully make informed decisions in case something were to happen, just like it did with the deer population.
I'm going to go over our mathematical representation of our population growth as limited by our carrying capacity. So this can be expressed by our logistic model, as Ms. Moore wrote on the board. And this equation is the change in population over time. So this equation is R times N times the quantity of K minus N divided by K. This may seem like a lot right now, but once we explain what each of them mean, it will make much more sense. So R is our natural growth rate of the species in absence of predation. So for this equation and for what we do later on our Excel spreadsheet, we're pretending that there are no predators. We're just dealing with the amount of the population and our carrying capacity. And then N in this equation is the population of the given species. So that'll be the number initially that you start with, and then the number that your population grows by. And then K will be our carrying capacity for the species in the given environment. So that is however many rabbits, say, you can have in this environment, and that will be your limit of rabbits for this population in the ecosystem. Go ahead and try out this equation, and I'm going to give you guys some numbers so that you can try plugging them into the equation on your own, and then we'll go over it together. So for R, we're going to use 40%, so in this equation it will be 0.40. And for N, let's say we have a population to start with of 50 rabbits. And then our carrying capacity, or amount of rabbits that we can have total, is going to be 200. So you can't have more than 200 rabbits in this population. So then we would give students a couple of minutes to go ahead and try this equation on their own, and then we would do it on the board together to make sure everyone got the right answer. Students have some time to do this equation on their own. We would come back and do it together and make sure they have it all filled out correctly. So it starts again with R times N times the quantity of K minus N divided by K. So we have our 0.40 times 50 times the quantity of 200 minus 50 divided by 200. And we would make sure that students had the numbers in the right area for our equation. And then make sure that they all got the correct answer, which is 15. So our rabbits would increase by 15. So then, to find our new population total, we take our 50 original rabbits and add 15, giving us 65 rabbits. So if we were to do this equation again, instead of using 50, which is our initial rabbit population, we would now use 65, because our rabbits increased by 15, and now we have 65 rabbits. So then we would make sure students understand this, and we would go over that, and then we would get into how to go over this on our Excel spreadsheet by giving them the equation that they're going to use in Excel and explaining how to plug that in on their computer by showing them the teacher's example.